This is a river, and this is a stream. What a beautiful scenery. And now, if we look down, we're gonna see the bottom of the river is covered by a thick layer of sludge. This is happening all over the country. And this is the operation of dredging and cleaning sludge. Dredging sludge is a necessary operation to maintain smooth navigation in water channels and rivers. However, the dredging process produces a large amount of sludge with organic matters and contaminants. This will have a huge adverse impact on human health and water environment. Still, the treatment of sludge is seen as a thorny problem because of its toxic nature and poor engineering properties. The traditional disposal method, or we should say the easy way, is to dump the sludge into the sea or the landfill area. Of course, this will cause the secondary pollution. However, with the awakening of global environmental awareness, such methods have been restricted by national and international regulations. Therefore, for solving this problem, a novel idea using sludge as the raw material of brick production have been proposed by many researchers. In recent decades, sludge has been used in different kinds of brick production, among which are fired and unfired brick. Fired brick require high temperature heating. It will cause a lots of energy consumption and carbon emission. Therefore, it's not a feasible approach for sludge treatment in terms of the environmental concerns. In contrast, unfired brick seems more sustainable and eco-friendly for sludge treatment in brick industry. However, this method also faced two main challenges. The first is that normally the water content of sludge is very high. This will affect its mechanical properties. It's like the experience we played the mud when we were kids. If you add too much water on the mud, it won't shape. Therefore, in most of the engineering project, the sludge is dried in an oven, or the water of the sludge is squeezed out by chamber filter presses. These are effective methods, but also expensive and energy consuming. The second problem is that the main sludge treatment method all over the country costs a lot of cement. Everyone knows the manufacturing of cement is responsible for 7 to 9% of global carbon emission. Besides, the production of cement also require high temperature heating and mining of raw materials. Therefore, our goal is to create a safe, sustainable, eco-friendly, and cost-effective sludge treatment method. Then, occasionally, we found these problems mentioned above could be easily solved by reusing two waste materials. Hemihydrated phosphogypsum, we call HPG, and slag. The hydration of HPG need plenty of water, and river sludge, as we discussed, has too much water. What a coincidence! The HPG is directly produced from phosphogypsum at 180 degrees. And the phosphogypsum is the byproduct of phosphate fertilizer. China, as one of the largest agricultural countries in the world, every year produces more than 70 million tons of phosphogypsum. However, only smaller than 10% of them is recycled. This figure is even smaller than the average recycling rate of the world of 15%. Therefore, using HPG to dewater sludge not only reduce the water content of sludge, but also improve the recycling rate of phosphogypsum. So after several months of hard work in the lab, we finally found the optimal proportion between different materials. The brick is 48% of sludge, 32% of HPG, 16% of slag, and only 4% of cement could get the highest strength, the strength of 30 megapascal. This is equal to the strength of concrete. More importantly, the utilization of waste material in this proportion could get 96%. So, mostly using waste material, we produced concrete-like brick. But still, we haven't completely achieved our goal, because some of the material we used in this study need a lots of pre-treatment, like HPG. But we are pleased to claim that we prove the feasibility of waste disposal by reusing other waste materials. So let's expect the better and cleaner environment in the future. Thank you.